Hello, good morning students. So we're continuing with the chapter Boolean algebra. So we have started this is the second video. If you have not watched the first video, please go and check that video. Okay, watch that, understand that, and then only you can understand this second video. Okay, so today we'll discuss about the postulates or laws of Boolean algebra. Okay, so Boolean algebra is defined by a set of elements, that is a set of operators which operate with the elements as operands. Okay, the elements are acts as the operands, and a set of axioms or postulates. So Boolean algebra, being a mathematical system, is based on the following postulates or laws. So the first one is the commutative law. So it states that x plus y equals to y plus x. So these are the operands, and this is the operators. Okay, so it proves that the order of arrangement of the variables or operands does not affect the design of the logic circuits. Okay, so even if you change the order of x plus y to y plus x, it doesn't matter. Okay, so with this example we shall see the proof. Okay, if suppose x and y is 1, so 1 plus 1. Okay, so y is 1 and x is 1. Okay, so you get 1 plus 1 1 and 1 plus 1 1. Okay, so I just made this short. Okay, so you can prove LHS side and you can prove RHS side also like that. So this is just to show that when you put the value of x and y, suppose like 0 and 0, the outcome will be 0, right? Here also, if suppose y is 0 and x is 0, then you get the value 0, so which proves that LHS equals to RHS. Clear? So again, here suppose like here 0 and 1, right? So if value of x is 0 and value of y is 1, here also value of y is 1 and x is 0, so it comes out that 1 equals to 1, which is again LHS equals to RHS. Okay, so this is proving the truth table of the logical operators which you have seen in the first video, right? The logical operators such as like logical and, logical or, logical not, right? So here the plus symbol is actually the denote by the this denotes the logical or, that is like x or y and y or x, like that. Okay, and so here the dot operator denotes the logical and, which is read as x and y equals to y and x. So this is the second law of the commutative. Okay, so here to prove that if x is 1 and y is 1, here also y is 1 and x is 1. Okay, the outcome will be as you have seen that in the truth table of the logical and operator. Okay, anything multiplied by 1 into 1, the outcome is 1. Or if you multiply it by 0 into 0, 0 and 0, or 0 and 1, or 1 and 0, the outcome will be 0, right? So that proves that LHS equals to RHS. So this is commutative law. Okay, next is the associative law. Okay, and next is the distributive law. So in associative law also, here that x plus y plus z. Okay, so that is like I'll just read this as plus. Okay, this is or, that is x or y or z. Okay, like that. So if the order of this addition does not matter, so that is like if you add these two first, okay, or if you add these two first, x plus y first, okay, the outcome will be same. Or even multiplying also, if you add y and z first, and then or x and y first, after that you multiply with z, okay, then the output will be same. Clear? Similar in distributive law also. Okay, if you multiply, okay, after adding y and z, okay, the outcome will be same as this. If that means either this way execution or this way execution, it will be same. Similarly here also, either this way, the left hand side of the execution, or the right hand side of the execution, the outcome will be same. Yeah. So next is identity law. So under identity law, okay, here there are four types of laws here, okay, which are similar. So the first one is 0 plus x equals to x. So here uh, we have to prove that LHS equals to RHS. So here, if suppose x value is 1, so which means RHS is 1. Okay, so if RHS is 1, then here on the LHS we give the value 1. Okay, that is based on the truth table, because there are only two values, that is 1 and 0. We can enter in under Boolean algebra, right? So here 0 plus 1, since x is 1, so the outcome will be 1, right? So 1 equals to 1, which proves LHS equals to RHS. Similarly, if suppose we give the value of x is 0, so 0 plus 0, which will come 0, so 0 equals to 0. Again, it proves that this law, that 0 plus x is equals to x. Okay, so whether you write here x or 0 plus x is the same. Similarly, 1 plus x equals to 1. So here you can see that 0 plus 0 or 0 plus 1 or 1 plus 0 will be same, right? So here, if suppose you add x with 1, so the outcome should be 1. So here example, if x equals to 1, so 1 plus 1 equals to 1, right? Which proves that LHS equals to RHS. Similarly, if x is 0, so 1 plus 0 equals to 1. That is the according to the truth table of the logical OR operator, right? So which is 1 or 0 equals to 1. So which proves LHS equals to RHS. Okay, so using the logical AND operator, we multiply now. 0 0 and x equals to 0, right? So if x equals to 1, 0 and 1 equals to 0. Anything multiplied by 0 is 0, right? So here we see that if here we see that 0 and 1 equals to 0, so which proves that, okay, LHS equals to RHS, right? Again, if we give x as 0, so 0 and 0 equals to 0, which again proves that LHS equals to RHS 0. Okay, now another one is 1 into x equals to x. So here is 0 into x equals to 0, okay, and here is 1 into x equals to x. So now if I give the value of x as 1, okay, so 1 into 1 or 1 and 1 equals to 1. So x is 1, right? So LHS we get 1. So LHS proves RHS. Again, if we give x 0, so that is 1 and 0 equals to 0. So RHS is 0. So which proves LHS equals to RHS. Okay. So next is idempotent law. Okay. So here x plus x equals to x, or x equals to x. So here we give the value of x equals to 1. So now 1 plus 1 equals to 1, which is the right hand side 1, right? Again, 0 plus 0 equals to 0, which proves the right hand side 0. So again, similarly, under the idempotent law, okay, x and x equals to x. So if x equals to 1, 1 and 1 equals to 1, which proves the right hand side. And again, if suppose 0 and 0 equals to 0, so x is 0, right? So which proves the LHS equals to RHS. Clear? So these are the laws that you must memorize and that you must keep in mind whenever executing. Okay. So here, involution law. Now this proves that, okay, the x inverse, okay, inverse, that is the inverse of x inverse equals to x. Okay, so here example, if x equals to 1, so you know that when x equals to 1, the inverse of x within the bracket, the inverse of x equals to x inverse equals to 0, right? So now since x inverse equals to 0, so 0 inverse will be 1, which proves LHS equals to RHS. X is 1, right? So 1 equals to 1. Now if suppose x equals to 0, so x equals to 0, that means the inverse of x is, that means 0 inverse is 1, right? So now 1 inverse is 0, which proves that LHS equals to RHS. Clear? So next is absorption law. So here x plus x or x and y equals to x. So now we have to prove through the LHS. Okay, so LHS x plus x or x and y. Okay, so here we can split it up like x within the bracket, which is also same 1 plus y, which is if you multiply it becomes x into 1x, right? And then x into y becomes x plus y, right? Plus xy. So now we next step we can make this x dot 1 or x and y. Why? Because we apply the identity law, that is 1 plus y becomes 1 plus x equals to 1. So in place of 1 plus y we can write 1. So which proves that RHS x equals to x. Similarly, okay, x and within the bracket x plus y equals to x. So this is another one of the absorption law. Okay, so proving the LHS, x, okay, x x and x, okay, plus x and y. After that, here we write x plus x and y. So why? Because x and x is under the idempotent law. Okay, x into x equals to x. Then we can split this up into x, okay, 1 plus y. So now x dot 1, because 1 plus y under identity law is 1, right? So here it proves that LHS equals to RHS. Okay, so students, you study all these laws, okay, memorize all these laws, keep this in your mind, okay, and then go through these laws. In the next class we'll be studying about different theorems, okay, on that. So that will be all for today.